Assalamualaikum. Hi guys. In the previous video, we've learned how to determine the molecular geometry for basic molecular shape. However, there are one more case where the central atom has one or more lone pairs. So in this case, the molecular geometry for that molecule is much more complicated if the central atom has both lone pairs and bonding pairs. This is why we are going to take a look at the strength of the total electron pair. The strength of total electron pairs is depend on the three types of repulsive force. Repulsive force between bonding pairs with bonding pairs. Next one between lone pairs and lone pairs. And the next one between bonding pairs and lone pairs. So these three types of repulsive forces are going to affect the molecular geometry for the molecule where the central atom has both lone pairs and bonding pairs. We take water as our example. You can see that this is the molecular geometry for water. We got O, oxygen atom, attached to two hydrogen atoms, and oxygen also got two lone pairs. So we can see that there is repulsive forces between lone pairs and lone pairs. We indicate it as A. After that, we got the repulsive forces between lone pairs and bonding pair. We indicate it as B. And the last one, we got repulsive forces between bonding pair and bonding pair. We indicate that as C. So between A, B, and C, we got the order of strength for that repulsive forces, where A is the strongest repulsive forces, while C is the weakest repulsive forces. So A is lone pair with lone pair, B is lone pair with bonding pair, and C is bonding pair with bonding pair. So that is why the shape from here, kalau kita nampak, bila lone pair dengan lone pair sangat kuat daya tolakan dia, dia akan menolak bonding pair, tolak sampailah angle untuk C ini mengecil. So itulah yang kita panggil sebagai repulsive forces. Macam mana repulsive forces boleh affect shape of that molecule. For example, I got CH4, NH3 and H2O. All of them mempunyai basic shape tetrahedral. Tapi apabila awak lukis Lewis structure, CH4 memang akan stay sebagai tetrahedral untuk molecular geometry. Tetapi untuk NH3 dan H2O, molecular geometry for NH3 and H2O bukan lagi tetrahedral. Hanya basic shape sahaja. Kenapa molecular geometry dua molekul ini berubah? Ini kerana NH3 ada satu lone pair. So saya guna orange ni, ini area untuk lone pair. Dan water, dalam previous slide kita ada dua lone pairs. That is why bila dia ada lone pairs for that molecule, bonding pair ini akan makin menolak. Okay, strength untuk lone pair ini dengan bonding pair akan tolak-tolak. So menyebabkan angle untuk bonding pair with bonding pair mengecil. Bila kita label bond angle, kita akan label between two bonding pairs. Kita tak akan label antara lone pair dengan bonding pair. Tak ada angle kat situ ya. So dalam kes ini awak boleh nampak secara original tetrahedral, angle dia adalah 109.5 degree. Tapi kerana NH3 mempunyai lone pair, so lone pair with bonding pair ada stronger repulsive forces berbanding dengan bonding pair with bonding pair. So that is why this one akan makin tolak. And this one pun makin tolak. Sampailah bonding pair awak bukan lagi 109.5 tapi dia mengecil menjadi 107.3. And seterusnya, awak ada H2O di mana H2O ada extra lagi satu lone pair dan awak akan ada lone pair repulsive forces di mana tolakan ini akan menolak dan dia akan tolak sampailah angle untuk bonding pair with bonding pair between two hydrogens lagi kecil berbanding NH3, iaitu 104.5 degree. So inilah yang dimaksudkan dengan bonding pair, lone pair, bonding pair dan lone pair. Dan lone pair adalah yang paling strong daya tolakan dia. That is why angle dia akan jadi kecil antara dua bonding pairs tersebut. So ini adalah contoh yang saya tunjukkan untuk awak nampak order of repulsion. So from there we are going to predict the molecular geometry based on this flowchart. So we are going to continue how to determine the molecular geometry for molecule yang mempunyai lone pair di central atom tersebut. So kita akan continue in the next video. That's it for now. Bye.